But all of us are fine to stay through the whole thing, right? I mean,
Yes, totally.
we're all coming from different places.
We're only doing that because we
Not gonna
have.
affect you at all, right?
Yeah, we're only doing that because we have two Zooms open in the same little room, and just to preserve some bandwidth.
So once I go off that, you'll still hear me on the mic and you'll still see me on another camera. You just won't have interference from my laptop.
Okay.
Oh, and Medeia, when I gave this announcement earlier as well, but at your presentation will go until 4:55 Alaska time, and that's including time for questions and whatnot. So if you are all still presenting and talking at 4:50, I will give you a 5-minute warning. We don't have a good technological way for me to give you a non-verbal 5-minute warning, so I may just sort of interrupt and save 5 minutes, and that will happen if you're still talking at 4:50 and we're not moved on to questions. So I apologize in advance for potentially having to interrupt, but wanted to give you the heads up.
Hopefully it should be okay. It should be okay. Thank you.
And Johnny will monitor the chat to relay chat-related questions that might come in during that at the end. He'll handle that. If we get questions from the room, we may have to repeat them to you. They're not coming through loud. How you doing, Jorge?
Very well, thank you. You?
All right.
I'm jealous. I cannot be there.
I bet. Yeah, I would love to have you here. It's a great day today. Good weather.
Okay.
Oh, it's raining bad here.
Oh, yeah. It usually is here, but it's not bad today.
Yeah, better weather in Alaska than in Florida.
Yeah, isn't that crazy?
How are we on time, Johnny? What time do we start right at 3:30?
Yeah, we should probably go ahead and get started. It's a couple minutes over. I'm just going to make an announcement outside and then close the door. We're getting started in here if you're looking to join. Thank you so much.
I should just turn my camera off, shouldn't I?
Yeah, that'd be great.
How can I get back to that to do that?
Can I rest my feet on one of these chairs?
I think that's fine.
Okay.
This button right there.
These chairs are so comfortable.
Okay, I thought I was on sharing screen, wasn't I? No. Where?
Let's go back to
Different
Zoom,
view.
and then it'll be down here. Oh,
I gotta change the view here.
Yep. Mm-hmm. There you go. All right. Let me just make this tiny bit smaller so it all fits on the projector. Great. Okay.
Okay.
Thank you so much, Eric, and to all of our presenters, and feel free to take it away.
Okay. Gunakshish. Gunakshish. Skatin Kwan. Gunakshish everyone for coming today and for watching online. And Gunakshish to the organizers of the Sharing Our Knowledge Conference. My name is Eric Hollinger. I'm with the Smithsonian's National Museum of Natural History. I'm adopted Duck-Loedi clan. My Tlingit name is Duck Wu from Hutsnuwu Kwan. And I will be starting our presentation today, and then it will be transitioning remotely to Lori Collins and Jorge Gonzalez at the University of South Florida in Tampa, and Medeia Csoba DeHass in the University of Missouri, Columbia. So we hope to have smooth transitions here. But I'll be starting off the discussion because we want to share with you what we've been doing in relation to 3D digitization of cultural heritage objects, particularly with the Tlingit. Our work started with the repatriation of this killer whale clan hat to the Dakloedi clan from the Smithsonian's National Museum of Natural History to Mark Jacobs Jr. And then the hat was, after Mark passed, the new clan leader, Edwell John Jr., brought the hat to the Smithsonian to have it 3D digitized so we could make an exact replica of it using 3D milling technology. So this carved a new hat, and it was painted and shell inlay made on it to make a full hat. In 2012, it was revealed at the clan conference, and then it was put on exhibit at the Natural History Museum and entered into the collections. So we could tell the story of the repatriation and talk about the importance of clan hats while the original, the sacred object, is used in ceremony in Sitka. The two hats have the unique, we have the unique relationship with the clan on the replica hat, in that they have the authority to check it out and dance it, use it as regalia when dance groups come to DC, and that's what you see here at the Natural History Museum. They've done this several times, so it can still serve as regalia, although we do not treat it as atu. 3D files for the killer whale hat are posted on the Smithsonian's 3D viewer, the Digitization Program Office, with the caveat that they are not allowed to be downloaded and printed. So this is one of two objects, ceremonial objects, that cannot be printed from their viewer. So the clans still have control over those objects. The other one resulted from this project. The killer whale hat project revealed that the technology could be used to reproduce in full a Tlingit object. And so that naturally led to this project, which Harold Jacobs thought of, was to work with a broken sculpin hat belonging to the Kiksadi clan of Sitka in the Smithsonian's collections, and asked us to use the technology to digitize it, but then digitally repair it in the computer and create a new hat. So that was done, and it also is on the 3D viewer. And the replacement hat, the replica hat that we made using that technology, just like we did with the killer whale hat, was actually brought out in ceremony and made atu. As far as we know, this is the first time that a museum-made object has been consecrated as a sacred object or ceremonial object of an indigenous community. It shows the potential for the technology to be used to restore or replace cultural heritage objects in museums or in private collections, or in the case of a lot of clan leaders, they recognize the potential for them to serve to digitally archive the files in case something were to happen to them in the future. We brought this technology to sharing our knowledge conferences in the past, beginning with the 2012 conference when we brought the killer whale clan hat to Alaska. We also digitized other clan objects, other atu at that time. Here we see a Dakloedi big killer whale hat. We also scanned the Kiksadi frog hat from Sitka at that time. And in 2017, we returned to Sitka at that time, and here you see a Dakloedi killer whale hat in the background and a Luknahadi Koho hat in the foreground being digitized. Gunakshish to the clans for permission to show these. Also, in 2019, we digitized the beaver canoe prow from Angoon, the Deshitan. Gunakshish to Garfield George for giving us permission to show the images that resulted from that work here in this project. And in 2019, the University of South Florida team that you'll be hearing from in the rest of the presentation joined us, and so they helped participate in the digitization, the digital capture of these objects. Here we see Tekwadi hats, Gunakshish and Dan Brown for authorizing us to show these. The mother bear hat on the left and the man who married the bear hat on the right, which was repatriated from the Museum of the American Indian. The mother bear hat was particularly challenging to scan because of its sheen and its darkness, and so it was a challenge for Jorge to work with there, but Dan Brown participated directly in the scanning of this hat, and he applied some talcum powder to it to reduce the sheen to allow the scanner to be able to pick up there. He also helped disassemble the hat and remove the paws, realizing that if this hat were to drop, it's very likely that the paw would be what would break off. So by digitizing some of the pieces separately, in the future, if something were to happen to the hat, an individual part like the paw could be reproduced. So it was scanned separately there. Also, Gunakshish to Mike Tagabon, Wushkitan clan leader here, authorizing the digitization of 2 shark hats. Now I will turn it over to Jorge and Lori so they can describe in detail more of the file process. And once these have been captured, sometimes we don't do anything with them in case the client asks for us to do more with it. In this case, they will show what's capable of doing next with them. Good sheesh. Take it away, Lori and Jorge.
And thank you, Eric. I appreciate that introduction. And I wanted to start by saying that Jorge, although he's not speaking much here, we're presenting a lot of his work. And so I want to give him full credit for a lot of the data and things that we'll be presenting. So as Eric was saying, our relationship to start with began in 2019 with the Sharing Our Knowledge conference. Sorry. This one is on some kind of playback. So sorry. Slideshow, these timings. Sorry about that. So we started with this project in 2019 through the Sharing Our Knowledge conference participation with the Smithsonian, inviting us into the project and working with the different collaborations involved. And a lot of our work previous to this, although we've done a lot of smaller scale documentation projects, objects and things from museums and collections, a lot of our work also involves different ranges and scales and different types of scanning for cultural heritage, including whole sites and landscapes that I'll share with you a little bit. We use a variety of different types of tools in that process. So primarily the types of tools that we're looking at for the digitization of the hats involved these handheld, almost look like irons, very small kind of handheld portable devices that utilize light to capture and make measurements, geometric understanding of objects. And so while we're using those tools primarily for these purposes, we also use different classes of instruments that can go out hundreds of meters and collect architecture and landscapes and building facades and all different types of resolutions and scales. And then the other kinds of tools that we typically utilize involve creating spatial location information, like from GPS, or what you do with the data afterwards. Things like virtualization and computer visualizations, VR technologies. And then sometimes we're also using tools such as drones to capture these landscape kinds of level of documentation. So just to give you a brief kind of understanding of it, we do use a lot of more traditional kinds of toolkits as well, such as photography, primarily for modeling and texture capture. Although I will say that there are lots of new tools coming out and new ways of engaging with cultural heritage objects and museum collections that are exciting and offer great potential for really cost-effective means and kind of letting everybody have these toolkits. So we do want to mention that there's a lot of new developments happening in these areas as well. Some of the tools that you saw in Eric's slide are better for certain kinds of close range documentation procedures, things with very small level of detail, very fine carved elements. And then some of the scanners like we used for the hats are collecting information that's high level detail, but it's also collecting, for example, color information. So in the scans that we're going to show, the models that we produced, we actually did not utilize photography due to the fact that we did this documentation at the conference. And so there wasn't a lot of time to do the full kind of documentation like we might normally approach it, to do photography and scanning. So we opted to do scanning with the color capture from the scanner itself. However, you could capture external photos and use those to bring in that color detail even more. So really, while we're utilizing maybe one instrument for what I'm sharing tonight, oftentimes we're combining a lot of these tools to get the best results. And this can be done, as I say, for multiple types of scales. And so just for fun, I'll kind of share some other types of projects that we typically are involved with, which is full landscape documentation. This is a project we're doing with the National Park Service to document an earthen lodge at Okmulgee National Monument. This project is very instrumental in helping to preserve, but also allowing them to protect the site from maybe too many visitors or visitors that can't get down and crawl and enter into the structure this way. We can do things to kind of virtually present and virtually share information. But the primary focus on this one was documenting the site so that if something were to happen or they need to do repairs or any kind of restoration work, they have the data to help them to do that. And what this can help with is actually kind of seeing the full architecture of a site and kind of forensically doing analysis on it. So in this case, we were doing things like understanding how the structure was built through the structure. So from the earth area over it, removing that, now what you're seeing is the interior with the poles and the wooden structure elements in the roof. And then the tunnel itself. Then we can kind of peel that off and look at some of the timbers and how those are related to the structure. And then we can get down to the actual, the part of the structure that is from ancient times, which is the clay floor, and kind of looking at the topography and everything that we can see from the scanner that allows them to help protect the floor and make sure that no damage or that it could be repaired should damages occur. And in this case, we did even cross sections and profiles and things to look at the pitch and the elevation of the floor, and just sort of some of the changes that all the visitation and the adaptations that the Park Service has made through time might impact the site. So these are the kinds of projects that we're very typically involved with, and usually all of our projects have a theme of preservation, protection, consultation, working in concert for very applied kinds of projects. And so we were very excited to get involved with the Smithsonian and the tribes in working with different aspects of documentation with cultural heritage objects, both in the museum and through the Sharing Our Knowledge conference. And here we were doing things with the short range, close range instrumentation that when we capture these types of data, it's about half of a human hair accuracy. So we're getting really high levels of accuracy. And we're also collecting, as I say, color information along with all of those measurements. So this is a photograph of the red shark hat that Eric had shown previously. And you can see the very vibrant colors that comes from photography. With the scanner, what we're primarily interested in for the purposes of this project, we were interested a lot in the shape and the geometry and capturing all of those measurement details with the idea that sometimes these data could be very useful for conservation and preservation. So here I'm actually showing where Jorge has stripped the color off of the object so that we can look at it in detail and see things like tool marks and maybe look at the wood grain texture and other things that maybe having the color on an object may confuse the eye, or you may not be able to see quite as well. So it's nice to have both so that you can really see the full sort of forensic view of the hat. And so in this case, things I'd like you to notice are the abalone inlays, those shell inlays that are very hard to scan. Eric mentioned how we work together to apply some powder to some of one of the hats because of the sheen. They all sort of have elements on them that maybe don't maybe reflect highly, or maybe don't capture quite as well as other surfaces. And so Jorge has done a lot of detail work on these to kind of try to bring those textures back if the scanner doesn't capture them exactly right. Here we see again a different angle with the color removed and the color laid on. And again, that color is captured simultaneously with the scans in this case, but we could just as well have external photos that we, through a little bit more of Jorge's time, he could model and apply those photos to bring out the brilliancy of those colors even more. And in this case, one of the real benefits, I think, of laser scanning is this ability to slice and view orthographic and different perspective kind of images and slice details that allow us to see sort of the interior makings of structures or hats in this case. And so here we're seeing a slice through the center of the hat, a digital slice through the center, and being able to see that interior structure in relation to the exterior from different angles and different perspectives. And where this comes, into critical roles, certainly with reproduction, as Eric showed some brilliant projects with the reproduction, but also think about restoration and conservation and that what if factor, these data can be very critical or can play a really powerful preservation role for making sure that these hats persist through time. Again, without color and all of that detail that you can see, that having the color might not allow quite the same level of visualization. Here we're seeing all of the nails that are used to tack the material on the inside of the hat. We're also seeing the actual cuts for the abalone inlay areas. So this is the cut in the wood that the abalone then piece would sit down into. And then having the color as well to look at, not only the paint applications, but in relation to maybe the wood grain itself and the actual small areas of, marks and use along the use wear along the edge of the hat. And then these are some really interesting views that I think are valuable both for visualization, but also for understanding sort of how the hat was made or how the hat actually functions. And so thinking about, what does the interior look like in relation to the exterior? So this looks like an X-ray, but what it really is that we have captured with the scanner the interior and the exterior so that we can put it in a transparent view. And we're now able to see the interior of the hat and where it sits in relation to the exterior. And we'll show some really important kind of things that learning kinds of things that came from looking at the data these ways. And I think that it also is interesting because we don't see the object this way, right? So we're never able to kind of appreciate how the inside works with the exterior. So scan data can be very powerful when you are able to visualize it and model it in certain ways. And again, this next example will be another shark hat that we worked on in coordination with Mike Tagabon. And this one is the gray shark hat, the alderwood hat. And this piece, this hat is really interesting from, again, a color perspective, all of that iconography. And it also is interesting because it has a movable part on it. So the mouth on this piece actually moves. And Jorge has created an animation as well that we won't be able to really share well tonight. Maybe at the end we can try it, Jorge. But I'll show you how that mouth articulates, and then how all of these wonderful inlays and everything were created, and capturing all of that detail was an important part of this piece. The shape, obviously, a little bit different with that mouth opening. It has this cavity inside. And what was interesting here is when we scanned the interior, Jorge was able to pick up all of the paint, showing that there's a painted tongue on the interior. And then there's also painting on the interior of the mouth that articulates. So there's teeth representations along the edge of the mouthpiece here. And this piece had a spring on it at one time, we understand, that is no longer functional. However, we can digitally move things to kind of show how they might have worked, and work with restoration of the object in that way. So in this case, the hat is shown again in profile and a section to kind of show interior to exterior. And then again, looking at this without the paint, I think, again, this one is a really good example of how we can see tool marks, how the wood was shaped and worked, how the actual grain of the wood was utilized in the construction, in the making of the piece, how they went with or against grain. We can see all of the cuts, if you look all along the edge of the mouthpiece, how this was cut out. And you can even see some triangular sort of design elements that are picked up when you don't have the color on. You kind of see that aspect that appear to be triangular, like teeth on the exterior of this as well. So again, having that color removed can be very valuable from an analysis standpoint. But then when we add the color, the full vibrancy of the piece and all of that wonderful symbolism and everything comes to life. And again, this is scanner color capture. And here we have the mouth open on the hat to show that articulating kind of movement. And here's where the full color of the piece. And then looking at this one with that transparent view, again, a lot of kind of interesting aspects when you think about how the hat fits, how it would have been worn, the weight of the piece, the volume of the piece, all of these things that can be analyzed with that kind of data. And also when you look at this, you can also begin to understand methods of how they would have made the piece, and how craftsmanship kind of aspects of what work went into the piece. And so the power of the scan data in this case also can be preserving the actual techniques and the craftsmanship, and being able to work together to share that, so that outreach and education to different generations can continue, maybe utilizing different types of technology. So it offers another method for interacting. And also, I think it's really important from a conservation aspect, because this piece in particular we were talking about had these paws and different appendage kind of pieces that are in addition to the body of the hat, and that if the hat were dropped, these pieces definitely would be the first to break off. And so as Eric explained previously with the mother bear hat, Dan Brown actually worked with Eric. They removed these pieces. Dan also used a little bit of a powder device to help with the color kind of helping with the sheen, lowering the level of shininess so that Jorge could get a better scan. This piece was interesting too because it has hair, and it has all of those wonderful sort of inlay objects from both the teeth and the eyes, and then those paws that are also on the object. And so in this case, this is a photograph just to show all of the hair connections, how all of this would, affect if you were scanning that. If you're scanning this is very noisy, very hard for the scanner to kind of deal with that hair element. So what we were most interested in was how the hair was attached. And so these holes all along the face of the mask and up the ear here, we wanted to do a very good job of documenting all of those areas where the hair actually was attached to. And so that was a little bit of a challenge for Jorge. And now you're looking at a render from one of his final models of the piece. And you're seeing the hat with all of the pieces still articulated to the hat. And the only thing that was removed, I should say, were the paws. Nothing else was removed on the hat. You can see that the color, again, this is scan data color, so it's not exactly matching, however, very, very close, depending on the lighting and the things, the shine and the texture of the paint, which can impact the scanner data acquisition of it. Here you see a really good kind of close-up of all of those holes where the hair was actually is actually attached, and how that kind of works and functions. So the hair has been removed digitally. Again, we didn't do, nothing of that nature was done to the hat to document it. So it's kind of interesting that the scanner allows us to do these kinds of things without impacting at all. We can still visualize and see things without the need for altering something or changing anything. And here, in fact, although the paws came off and we scanned them separately, Jorge was actually able to digitally remove all of the other parts so that it could be appreciated, all of those additional pieces that went into the making of this hat. So here we see all of the teeth, all of the eye inlays, the metal copper eyebrows with the hardware that was used to attach them, and the ears. And so all of this, again, is only a digital representation of removal. We don't have to actually remove these from the hat to be able to see them in this way. And here we see all of those inlays, and all of the different hardware from a different perspective. I do want to point out, this is something that came about interestingly in looking at the data. This little hole right here through the eye. So this is actually happening from where? The thinness of the wood in this area is so, it's very thin through this area. And so you would not see this because this was covered with the inlays. However, we know that it's there from data taken from a different perspective. So I told you before, I showed you how we can slice through virtually the hat to kind of reveal those section understandings. If we look here where we scan the interior, there's that hole. And so through exact measurements, we're able to know that that hole articulates to the outside exactly where I previously showed in this. So that's where it would come out. So this is an approximation of what is happening to the object underneath the inlay. So we know damage is there. And so this is an interesting way that we can think about potential needs for repair or conservation when we do these kinds of forensic studying of the actual scans. in this case too, again, we're scanning from all the different angles. So all of these different, through the years, the different attachments, the different straps and devices that went into the hat, those kinds of things become evident so that we can kind of understand the hat through time, and changes made through time through the scan data as well. And this is a beautiful one, I think, to look at in transparency, to see that interior portion of the hat in relation to the exterior and how the hat is worn and what that looks like on the inside, because there's no other way to really kind of appreciate that, I don't think. So these transparent views are really interesting. And this one is my favorite, I think, because it really shows that the it's not symmetric, it's not even, it's you know, has a life, right? And so this is really kind of powerful to see that interior with the exterior, I think is a really nice example of how these transparent views can be helpful. And then the last piece that, or I think second last piece, sorry. This is the other bear hat that we scanned, the man who married the bear hat. And this one is very vibrant colors, very much more red than what is captured by the scanner. However, the all of the details that I'm talking about with the shape, the morphology, the measurements of the piece, all of these aspects of need for repair. This hat has a lot of damages to it along the edges and has some pretty significant cracks that have occurred. And so here you see some of those cracks and one that's been sort of repaired here. And just as we removed the pieces digitally, Jorge was able to kind of pick the piece apart without really picking it apart. He did it digitally. He's also able to make repairs digitally so that we can evaluate in a digital environment how a repair might impact a hat, or is it a good fit? Is it the, so I think these
Lori, you're frozen on our end.
to do that with. Question?
Temporarily.
Okay.
You just repeat the last 30 seconds.
Sure. So I was saying that I think that the scans offer a really good way to collaborate and to work together on repairs and restoration of these hats, because you can do it digitally without changing anything. And the repairs can be made and studied and understood in a digital kind of way first, before anything has to be done to the hat. And we can understand how repairs change the hat or might be done a better way. So I think that this hat offers us a really good example because it does have all of these cracks, including one that has been repaired here, that a digital restoration as a first step would be a really interesting path forward for the long-term preservation of the piece. Here we have a top-down view that kind of shows where all of these appendages and added materials on the hat exist, that, again, we scanned them with those pieces in place, and Jorge has digitally removed those so that we can see the surface of the hat. So you're seeing all of the holes, and we can study the angle and things for those appendages. The color, the cracking here, again, the color is from the scanner, but this scan has so many applications for long-term preservation, including, like I say, understanding the interior to the exterior, the warping that's occurring with the wood, all of that can be kind of seen and understood. So it's important for replicas or reproductions like we saw early on, but also this idea of conservation and preservation and long-term kind of assistance and help that can come from scanning on these hats, I think is critical. And again, same kind of view, offering the transparent understanding so that you can see the interior of the hat to the exterior in ways that you would never be able to see it otherwise. And then the last piece that we'll show is the beaver, the canoe prow that that Eric showed earlier, that was scanned and documented in 2019 as part of the Sharing Our Knowledge conference in that year. And this piece was challenging primarily because of the color of the piece, very vibrant color. However, we, with just the scanner, captured quite a bit of the color detail. This piece has a lot of cracking and surface crazing, surface loss of paint. Some of the hardware utilized on it has some deterioration to it. So being able to really document the piece in a way where we can look at conservation ideas in a digital way, I think is really powerful for this piece as well. Here we see not only cracks, active cracking, but ones that have been repaired through time, and different elements where things are added to the piece, how the piece might have changed or been used through time. Is interesting to see all of these details, including the wood grain texture and the tool markings and cuts that were made by the makers of this incredible piece. Here again, showing without the color, all of those inlay areas on the eye and the teeth, these that material highly reflective, so very hard to document with the scanner. However, Jorge, in working with the data, is able to really apply those colors and textures in ways, even though he did not use the photogrammetry or external photos that we sometimes would likely use for pieces like this in conjunction with scanning. Here again, without the color, again, all of that wonderful carved detail that you see, all of those tool marks. And then here with the color showing, you can really see the artistry and all of the work that went into the iconography and the elements, the symbolism on the piece. And here again, although this is not a hat, this having the interior to the exterior is really powerful here as well, seeing how that connects and sits in place, and from different perspectives and views, with all of this design to see from different angles, I think is really interesting to see in 3D, because it was meant to be seen, part of it's meant to be seen from the underside and above. So having a piece like this in 3D offers some powerful ways of understanding and sharing as well. And I'll kind of end this section with an animation that Jorge produced for the beaver prow. And this kind of showcasing the sort of level of detail of the documentation, but also all of the dimensionality and the exact kind of surface measurements and textures that were captured with the laser scanner. And I will say that, I talked about there being different tools, and there's lots of different ways to document pieces like this. And it really depends on what you ultimately are thinking of doing. So if it's for replica production, you really do need that exacting measurement kind of data that's coming from these types of instruments. where we're able to have exact metrology, exact measurements that we're able to kind of replicate from. Really important to have high level of detail if you're looking for conservation treatments and you have to visualize and understand models in ways like this, where you need not only the color detail and the object shape, but you actually need the measurements, the geometry data underneath. And then the other thing that with the piece like this, there's ways that you could utilize things like phones or photogrammetry to document pieces like this and still have very meaningful end products, but they may be meaningful for different purposes. So maybe not for replication, but maybe for virtual display or kind of education kind of thing. So there's different ways of different tools. And what we're showing here is very much higher end kind of scanning tools that were applied to these projects with the idea that we wanted to be able to show the ability to replicate as well as conserve and preserve and interpret and kind of share and work collaboratively with these data sets. So that's going to end mine, and I'd like to introduce Medeia DeHass on the next portion of it. And I think I just stopped sharing. Is that correct?
I think I should be able to. Can you see my screen now? Can you hear me okay? Okay, perfect. Well, thank you, Laurie. And moving to the next section. So we thought in this section, we would like to share some information about the preliminary results of a parallel project that we have going, and which is focusing on the ethics of using 3D technology to preserve cultural heritage. And some of the examples have been mentioned previously, both by Eric and Laurie in the previous section of the presentation. So this parallel project, it's a National Science Foundation funded 3-year project, and we have just started our final 3rd year. And so we have a lot of discussion our teams have been having to draw on as I'm moving forward with this information. So you've seen some of the applications in the previous slides and the capabilities of 3D technology, and also the ongoing work and the examples Eric, Laurie, and Jorge covered. And we thought it might be helpful to sort of think about some of the broader consequences as well as the opportunities 3D technology provides. While there are only 4 of us in this presentation, our project brings together 13 team members. We had previous team members who cycled out. Currently, there's 13 of us. And so we are looking at the ethical use of 3D technology specifically to preserve Indigenous ancestral heritage. And we are looking at the 3D digitization, dissemination, and potential 3D printing of Indigenous material heritage, as well as the potential ethical issues that may arise from using these technologies. For this reason, our project, the specific ethics project, does not engage in any kind of 3D digitization. Instead, we were looking for team members who have experience using these 3D technologies, and so we are drawing on their experiences. We also bring multiple identities to these projects. Some of us are coming from an archaeology background, a 3D technology background, working with Indigenous communities, cultural heritage preservation background. And so it was our goal to include Indigenous perspectives from multiple regions. And so we have team members from the Bering Strait region, from the Kabarak region. The Tlingit region is represented by Edward John Jr. We have the Gabrielno Tongva, the Los Angeles area, and we also have Sami expertise from areas of Norway and Finland. Ultimately, our goal is to co-offer a set of responsible conduct of research guidelines that will kind of dig into some of the issues we have been discussing today, And we would also welcome your feedback and any ideas you would like to share with us. What is it that you would like to see in this RCR guidelines? Like I mentioned, this is still ongoing, and we are just at the last phase when we are putting together this information. We would like to make this very user-friendly and helpful to any organization who are trying to kind of develop these 3D projects, and so include information that would help them with that. It is not our intention to set any kind of limitations on how 3D technologies can be used to preserve Indigenous heritage. Rather, we would like to outline different approaches and then some of the concerns and some of the benefits that we have experienced in our past work. We envision that this guidebook will provide information for multiple sectors, including the potential to inform policy moving forward, but also tribal organizations, museum, archives, heritage preservation projects who are looking to develop new digital heritage preservation approaches. So we would like to provide a planning and project management tool that can help tribal organizations realize their own heritage preservation goals on their own terms, because this will be different for all communities. So for this reason, in our work, we use a co-production of knowledge framework that was developed by one of our team members, Julie Raymond Yacobian, and her collaborators, Carolina Behe and Rachel Daniel. So at the core of this framework is the intentional participation through equity in design process and data dissemination. And because all participants come together with the intention to contribute, they can negotiate their shared goals. And those goals are continually revisited to make sure that they still fit the expectation that were set out at the beginning of the project. This includes discussion on what type of data the project will produce and what type of access, sharing, and reuse will be appropriate for that particular project. For example, you have seen Lori's and Jorge's work in the past few slides, and you may be wondering what happens with the digital 3D data that can be actually used to create a replica of the original A2. And so they worked, when they worked on this project, and the project has concluded. So in our guidebook, we are basing all of our discussions on the concept of Indigenous data sovereignty, and will include details on what type of data can be protected and how it can be protected in order to prevent unauthorized replication or use. But unauthorized models are only one of the many concerns that have come up during our team's discussions. And it is in the top 3 concerns for sure when it comes to looking at how 3D technology can be misused when it comes to Indigenous heritage, cultural heritage, and it can endanger actually these heritage pieces. Today, anybody with a pretty good cell phone can walk into any museum or go to any heritage site and create a solid digital 3D model of any ancestral heritage. Some of the phones even have LiDAR or scanning capabilities, but these models will not be good enough to print a replica from, just as Lori had mentioned, but they will be good enough to be uploaded into a sharing site and sold, being allowed to be downloaded from there as a digital asset for a video game or, any other kind of digital production. And this is not a hypothetical concern. This is something that's happening. And throughout our work in the past 2 years, we have documented several cases of this exact thing happening. Another concern is models shared on the internet that, while not downloadable, so they can be misused in that way, but they are not for sale, but they are completely void of any kind of cultural meaning. So basically, an uncontextualized model of an A2 without proper representation or any sort of engagement with the rest of the knowledge and cultural system. Currently, most museums and heritage preservation institutions that have Indigenous collections use this approach. And in part, it happens because they simply don't have enough people and experts working for them to provide full context for all items they digitize. So they often opt to prioritize the digitization itself instead of the cultural specific representation. While everybody knows this is not best practice, it is the most widespread practice at this moment. And we are hoping that our RCR guide will help folks kind of reconsider that and find ways that culturally specific contextualization can be included in all of the models. But we've seen a lot of the positives as well, a lot of the benefits. And so the top three that comes up is, preserving cultural heritage for future use. And this future use can, as Lori mentioned, can include documentation in case something happens. There's a fire. We've seen fire actually destroy a lot of cultural heritage in the past few years, but it can also be for repairing pieces or to see what a repair would do to a piece to kind of as part of the heritage preservation process. But the digital 3D models can also be used to provide sort of controlled access to all tribal members in a properly contextualized context. So the burden of having to travel to a collection or sort of this gatekeeping that only certain people might have access to it. For instance, you have to kind of negotiate with the curator to have access. That can be removed. For example, the actual piece may have been repatriated already to a community, but the digital model can give you access to it even after the repatriation has happened, so that it can be used for education purposes, or it can be used to actually create a self-representation. Using digital 3D models to tell Indigenous culture-specific perspectives provides a very strong platform for self-representation and gives you a tool, gives communities a tool to take back the narrative about their own culture. And lastly, some of the key concepts our team has been discussing can be grouped around the process of using 3D technologies. Because we are focusing on Indigenous heritage, it has been our experience that a team approach to projects can be particularly beneficial. A project that includes Indigenous community members, 3D technologists, and cultural heritage professionals from the very beginning of the project, really just when it starts out and just the planning starts, and when everybody's on board and working together is when we see the best results. It can create a sort of synergy that would meet all participants' expectations. For example, many 3D technologies can be learned quickly, but to master them takes time, and assembling a lab where there is a technology, high-level technology and expertise to run those technologies are present takes a lot of time and a lot of money, and actually a lot of ongoing upkeep, which is something I learned while we were working on this project. So maybe if the project's goal is to create the highest quality models, just like Lori just mentioned, then it makes sense to partner with a lab that already has those capabilities and experience in working with Indigenous communities. But if the goal of the project is education, maybe the best way to look at it is invest in some of the technologies so that children can go out in the communities and create their own 3D models and bring in folks who can provide the training. So matching the goals, the project's goal to the capabilities is something that we've been kind of considering and suggesting moving forward for teams to think about. Then the last section I'd kind of like to highlight in this discussion is looking at bringing in Indigenous knowledge systems into the process of 3D modeling items. For instance, does the tattoo need to be addressed or handled by a certain member of the community? Is there a specific ritual that need to be performed? How can this process be adapted to that particular community so that it does fulfill their own expectations what they had for this project? And we spend a lot of time thinking about the data we produce in our 3D projects and how they can be shared and protected at the same time. We follow the CARE principles that were developed by the Global Indigenous Data Alliance, and our recommendations are based on the expectations that Indigenous communities will own and control all the data, including 3D data, as well as the future reuse of that data in these projects. So for this reason, we will have a thorough section on data management plan recommendations and discussing some of the options that can be adapted to community-specific circumstances and heritage preservation goals. Nalshish, thank you so much for your attention. And if you would like to share your ideas, we would be very thankful.
So now we turn to the audience for questions, and in particular, we'd like your feedback on these challenges, these benefits and potential concerns surrounding 3D and 3D ethics around this technology. Any questions or comments? Can you see this technology being used with your material culture?
Yeah, because we have, there's not a lot of research back home on our land, but there's a lot of old sites that we have that are falling apart that have been captured in 3D, and it was just one person tried it out, and he was able to scan one place down the end of our lake and preserve it as is. You know, it's not fully preserved, but I can see that someday, like possibly going to all of our old sites and even the historical sites and possibly rebuilding them in digital form, you know. That would be pretty interesting, because the place where we live now, it used to be an island. It used to be surrounded by water, and that island was, what I was told, it protected us from the animals, from dangerous animals, eh? So it would be interesting to use this platform to animate that, to show people. And we have examples of old villages, but it would be nice to actually find a possible site and rebuild it using this technology.
So in case the microphone is not that strong for our guys on the other end, okay. So were you guys able to hear that? He's talking about in the Teslin area, in the interior, archaeological sites and village sites, scanning historical and potentially prehistoric sites and using those to reconstruct the sites. Yeah. And share the knowledge. In some ways, it sounds similar to, Lori, some of the scenes you were showing of that reconstructed house at Akmogi. Would you guys care to comment on that?
A lot of the work we've done has been with structural kind of documentation, but also with actual land formations that are sacred, mounds and middens, and sites relating to those structures. We've also used this technology a lot with petroglyph and rock carving sites. In Hawaii, we actually were working alongside a lava flow. So the lava was actually taking out some of the carvings and the petroglyphs in front of us. So we were trying to very rapidly document something before it vanished. And unfortunately, that happens a lot. You know, you can think of all kinds of reasons: war, development, climate change, you know, vandalism, looting, things that just happen both naturally and culturally that impact our heritage around the world. And so these kinds of strategies and tools are very useful for those kinds of measures. And also, I think it's important, like something that Medeia mentioned, which is that, you know, Jorge is incredible, but he can't be everywhere all at once, right? So having people with his skill sets that can work with and become, you know, teams of people that basically can help to document things before it's too late, I think is also imperative with certain types of heritage, like he's mentioning in particular.
Lori mentioned some of in addition to threats, we see things like Ukraine right now. There are people who are scanning statues and buildings that are being destroyed by the conflict there. And we see places like Notre Dame that burn, iconic structures that we assume will be there forever. They've been there a long time. We assume they're always going to be there. Nothing lasts forever. And so this adds to ways to document or restore. I don't know what they had in the way of 3D scanning on Notre Dame. They're, of course, trying to do their best to reconstruct it. The Brazilian National Museum burned to the ground, and there were, Harold says, 50 to 60 Tlingit objects in that museum, and he wondered if they had been digitized, could we restore them, let alone all the other objects that were destroyed in that collection. Hoona burned in 1944 and lost all of the clan crest objects except maybe 2 hats. So, the clan leaders that we worked with so far really see it as a potential to archive as security against those kind of risks, whether it's site destruction or loss of objects. So there's clearly a lot of positives, a lot of benefits to this. What do you guys in the room here think about concerns? Do you agree with some of the concerns we've heard from clan leaders that they're worried about digital files escaping and getting in the hands of commercial interests? People mass producing them in China and selling them on the market in the US and Canada and in gift shops, making killer whale keychains and earrings and things like that without the control or knowledge of the clan leaders being involved in that. Do you agree with that fear and that concern?
Yeah.
Oh, yeah. I was thinking, I teach middle school ethnomathematics STEAM with students, and every time we dive into it, I always want to start off of those cultural values. But it's shocking to me when I go right next door that my colleagues, well-intentioned, are doing these, but they haven't laid that basis of those. And it reminds me of the FAIR
The principles?
ethics. The FAIR principles, just like, and the concern of it being uncontextualized is probably more common than not.
And a greater risk perhaps because this technology makes it easier to share rapidly and broadly across space, so maybe even easier to become disassociated from the cultural context in which they are. Here we're at Clan Conference, at Sharing Our Knowledge Conference, and we're scanning objects, scanning Atu. I actually have a scanner here you'll be able to get to see in action during the conference in the other room. And in the past, we've scanned Atu that was in use in warming into the hand ceremonies the night before, or in other kinds of ceremonies. So they're going right from that into a context where we can scan that. But then what we do with that is a responsibility in that, because it could be taken immediately and quickly out into a context where it's totally severed from that context. It's so important here. When, as you know, when clan leaders talk about when the hat is brought out is important. The objects that are with it sometimes are important. Whenever possible, we try to have raven and eagle objects in the room together to balance out even the digitization process. So we are learning a lot from these experiences at Sharing Our Knowledge Conference. So we appreciate the feedback and hopefully the continued feedback that you'll give to us beyond now. If you think of things in the future, or even throughout the conference or later, and you want to share those with us as far as thoughts and concerns. The project Medeia described and outlined, it's ongoing. We hope that it will continue to grow and be informed by communities and their concerns. Right now, the Tlingit are among some of the few communities that have real-world experience with seeing this happen and participating in this happening. But people around the world are studying what we're doing here and are very interested in considering applying it to their own cultural context and to museums throughout the world. So we hope that you will continue to support us and allow us to try to do it better and to share that better as good models for how to do it. So, Gunakshish.
I want to make a comment because some of the stuff that there's a really deep meaning behind it. But one of my friends explained something where somebody saw this woman with these little pieces of, I don't know, hair or grass sticking out of her nose right here. So she explained to me what that was. She said that that woman is, there's a particular type of cat that's a good mother. She said this woman puts these little pieces of straw in her nose that are pierced because she wants to be a good mother like that cat. And there's a deeper meaning behind these things, eh? They're not just something to look at. Some of them are records of something very significant that happened. Like, oh, behave this way. This is good for your people. And that's what some of those objects are. You know, like this is something somebody did that's really significant, you know? And we're supposed to behave this, remember this. And sometimes it's those art objects and the oral history behind them, they have this meaning that enriched us. And it just leads back to kinship that has made us closer. You know, like a custom we have back home is if I walk up to somebody and just grab some food out of the plate and eat, it's like the old generation, they will look at their partner and they'll say, you see what they did? And it's like my mom told me, she said, you're telling them how much you love them. That you basically will eat right out of their mouth. You love them so much. It's just that little thing, you know. But that's some of our old customs. You know, I would go to my cousin and he'll be eating his food and he'll just push his plate to me. And it's a big meaning. It's a gesture of what he thinks about me. And no words shared. It's just these actions, these movements. You know, so a lot of those, and we're starting to remember them, what those mean, eh? You know. And it's just it's like this love language that's attached to some of those objects. You know. Luckily, we're remembering them. You know.
We hope that this technology can be used to aid in that, in sharing, because we recognize that in today's world, clan members can be dispersed all over the planet.
Yeah.
They may never get to see their clan objects brought out in ceremony. They may not be home at the right time to see those. So how do they learn about? How is that knowledge being passed on if they aren't there to witness? In the old days, they were there at the Kuiks to witness it. They saw it. They learned through the Kuik. They're not always able to be there for that, but this technology, in a sense, could stand alongside that, and clans could, as Medeia was describing, you could post objects, clan objects on the web, and you could have the clans tell the story of those objects, the history of those hats, the meaning behind them, so that it could be viewed and understood and examined closely and in 3 dimensions from a kid who's having to be raised in Australia because his dad's in the military or something like that. It could be accessible, and it could be controlled by the clan as far as what's relayed and told that way. So it's not right there to pass the food on, but it's maybe a digital surrogate for sharing that knowledge through this medium.
I have one more question or thought, and I'll try to keep it short. You mentioned the last time scanning it after the healing, the warming of the hands. Have you scanned or have you planned to scan a same atu after a celebration when it has been brought out versus checking it again at a still moment when the life isn't as present in that item? I'm just curious if the scan shows something different.
We have not had that experience to do kind of like a before and after. Kind of the objects that we've scanned at clan conferences, some of them were on museum shelves, like Sitka National Historical Park. They pulled Catlan's helmet and brought it in, and we scanned that, and Catlan's hammer. So they, in a sense, had been static and not used in action in many years. They had not been put together even in ceremony until we had them in the room and we're scanning them again after a very long time that they had not been in the same place together. And so, and then some objects had been in clan possession but not been out and used, not been brought out in a long time, and they brought with us. Others were regularly brought out. The frog hat was used all the time in Juneau and checked out of the museum and used and put right back in the museum for safekeeping. And so they pulled that and we scanned that. But we never scanned something that was before and after to see if there was any changes. And it might be something that would be difficult to detect if there were in that. The sculpin hat that we made or remade, you know, we took video of it before it was put in use in ceremony. But because it had so many ermine skins and whiskers and things added to it in the trailers, it's very hard to capture those in 3D and get to the root of it. What Jorge showed was that he actually erased the hair, erased all those things. He did a masterful job on that. That's not very easy to do. And so we have not seen things like the sculpin hat that was brought out in before and after. But that would be interesting project to attempt. We hope this will, in a sense, become more common, and we hope more Tlingit, Haida, Tsimshian young people will get interested in this. My hope was that they're computer savvy. They like this technology. If they want to use this technology and learn more about it, this is a context in which they can apply it and do some good and learn about their cultural heritage at the same time.
Do you have a training program?
We have the potential to host interns to get additional training.
That's what I do. I do 3D stuff. But
Oh, yeah.
I just haven't. I'm getting ready to go back to upgrade again because it's been a while.
Yeah. Yeah, the Smithsonian has some fellowship programs, some internship programs, and they're usually for college students because usually they're tied to a university program. And I don't know if University of South Florida has something.
Should be fine.
Yeah. Lori, I don't know, do you host interns or?
Yeah, we do. We have interns and also regularly we have students, and interestingly, our students come from pretty different, you know, interest areas. So we have students that are interested in like engineering and design kind of stuff, and then we have students that are history and anthropology, and then we have some students that are very much interested in GIS mapping technologies, because I had one student who was very interested in participant observation of, like, from the Indigenous perspective, like how they view the landscapes and letting them map themselves, like teaching them to map their own heritage, because especially with like sacred areas, there was just differences in the way that things were understood and mapped. And so I think, you know, we would be excited to talk about those kind of potentials. And Medeia, maybe you could talk, because she's in a brand new program and would probably love some students and things right now, right?
Absolutely. So through another project, actually, we will all be collaborating to create a video series on all of the technologies and how to use them, specifically to work with Alaska Native heritage pieces. So we will have folks from communities helping us better understand what would be needed. And we will look at not just the very expensive technologies, the high tech, but also the low tech. So if somebody wants to just get started and see how much, if they like using this technology and how it works out for them. And the series will also cover data management and some of the concerns that we just talked about. So if you're interested in that, please get in touch, and we're happy to keep you updated on all of the things that are coming out from these projects.
And it's eroding all the historical sites. Every year we lose a little bit more of it. It's pretty scary, actually.
Okay, well, thanks. I think we're over time.
You got 5 more minutes.
Oh, we do have 5 more minutes. Okay, well, keep going. Keep going, yeah. Yes.
Question. So you talked about how a lot of these 3D projects are kind of guided by the principles of Indigenous data sovereignty, and I'm wondering, like, how that is influencing, or it has the potential to influence, like, the relationships between people and their ability to, you know, like, reclaim or regain ownership over, like, the actual material objects that are sitting in museums that were stolen from their culture.
Yeah, that's a very good question. Did you hear that question, guys, on your end? Did that come through
Yes.
clear enough? Okay. Yeah, that's a very good question. And actually, a project we didn't talk about here was a project with Huna Indian Association, where we repatriated a number of shamanic funerary objects, and then Huna asked us to 3D digitize them, and we're working with them to make replicas, 3D prints of rattles and milled objects that, because the shamanic objects can contain yake in them that can be dangerous to touch or handle, so the Tlingit usually don't handle them. They also have pesticides treatment on them, and they also have mercury in the red paint that was used originally. So there's chemical and spiritual hazards associated with them, but they still felt they were very important artistically and culturally for people to have access to see and learn from. So they wanted a set of 3D replicas. And we entered a project where we made a set for us and a set for them, working together in how to make them. Ultimately, they were probably sequestered, the originals, and they will be restricted, but they can then handle and teach and pass around the replicas. They in part wanted to do that project to show that they could work with the museum to do that. They felt like it would be important to show other museums that they felt were resistant to repatriation, that they were open to sharing through 3D replicas, that if a museum would agree to repatriate, that the museum could potentially still have a replica of that if they felt it important to teach about it culturally and historically or to exhibit. And they felt that it has actually influenced those museums that, to sway them to make a decision to say yes in some cases. So in their opinion, it's already happened. It already has influenced some museums to change in their perspectives on repatriation. So that's an example, I think, of that. With what we do here at the Sharing Our Knowledge Conference, when we scan these objects, when we digitize these objects, they sign an agreement authorizing us to just digitally capture them, but not to do anything else with it without their clear permission to do anything more. Even for the 3D models that they showed from 2019, we consulted with each clan leader to make sure they were aware that we were going to show these, because it's something new that they hadn't seen yet. There's one thing to have it on the table and take pictures and authorize us to do that. This was then public display of that, and this is recorded. This will be shown in the future. And so it's important that they understand that and they be aware of it and approve of those uses. But they also then can consider making something for a museum or allowing a museum to show it and tell the story in 3D. They have, as far as we're concerned, they have control over that. So we're trying to serve as good models because others may not do that. Others may feel like if they scan it, they control it. If I have the equipment here, I'm doing it with my computer and my scanner, I control it. The traditional approach has been if you take the picture, you own it, right? If you're the photographer, you own that rights to that image. So we're, in a sense, we have to reverse it. For most museums, if the museum owns the object, they control the digital surrogates, the products from that. Do you guys want to comment on any additional examples or thoughts, Medeia?
I just wanted to add that the way we look at using 3D technology, it contributes to actually physical repatriation. It's just part of the process a lot of the times. Sometimes it can happen as kind of starting a conversation with collections. Sometimes, as I mentioned, it can happen after repatriation has happened, but maybe other community members would like to see 3D models. So it can kind of come in at any point, and it can add to any repatriation project. Also establishing very early on, and that's kind of, we're talking about the co-production knowledge framework, that all the projects will be developed together with the understanding of Indigenous data governance in place. I think having that understanding creates this space where team members can kind of innovate and experiment on what is it that works for them the best, and then move forward with that. So come up with new ideas that is very specific to that community or to that clan.
And I guess my final example that I'll give is an interesting project where these kinds of tools are useful not just for smaller, like the hats that we were showing, or a museum kind of object, but for, again, those landscape type projects. Years ago, it was common that burial mounds were excavated as part of an archaeological project, and a lot of those skeletal remains today are not in their context. And so we were part of a project team with the National Park Service to repatriate a large number of burials. But in working in consultation, the thing that they asked us to do with all of these fancy tools is to go out and scan the mound on the exterior and use ground penetrating radar to scan inside the mound from above, right? And then what we were able to do is we were able to match up our data with the old remnants of the trenches and where the archaeologists had previously dug. And we managed to match the map of the excavation units. And so we knew where all of the human remains came from that were removed from that. So we put the mound back together in consultation. We were able to provide maps to the tribes in this case who had a shaman ceremony and reburied all of their ancestors in their exact spots where they were taken from. So these kinds of technology and tools can be extremely powerful for righting wrongs and for correcting maybe some of those historical problems. So I feel, really privileged to work on projects like that.
That's a great example to end on, I think. So, Gunakshish everybody here. Gunakshish, Lori, and Jorge, and Medeia, for your work. Thank you. Bye-bye.
Gunakshish, thank you, everyone.
Thank you. Bye.
Okay.
No, Chishi, take care.